Hello everyone, welcome on our YouTube channel. In this video lecture, we are going to learn some concepts of the science. Physics made easy quota help you to learn more about the science. So we are going to understand about the work that in our daily life we use the word work more frequently. A student sitting on a chair learning his lesson usually say, please don't disturb me, I am doing work. But you will be surprised that in terms of physics the student is not doing any work. So we are going to understand about the chapter work, power and energy in terms of the science. So in this video lecture we are going to learn these topics. Please have a look at these topics. Law of conservation of energy. It states that energy may be transferred from one form to another, but it cannot be created or destroyed, which means that the total energy of the system always remains same. It can possible that the energy can change from one form into another form in a system, but the total amount remains same. Transformation of energy, that is a conversion of energy from one form to another, is possible through various devices. That is a mechanical energy get converted to the electrical energy. That is mechanical energy is utilized to make the electricity or the charge flow. Light energy can be converted into the electrical energy, example photoelectric cell. Chemical energy can be converted into electrical energy, example primary cell. And also chemical energy can converted into the heat energy, for example burning of coal. Sound energy converted into electrical energy, example microphone. And thermocouple, which shows the conversion of heat energy into electrical energy. Also engine, it shows the conversion of heat energy to mechanical energy. Motor, electrical energy to mechanical energy. Heater, electrical energy to heat energy. Speakers, electrical energy to sound energy that help to listeners music. Voltmeter, electrical energy get converted to chemical energy. Bulb, that is the electrical energy get converted to light energy. Mechanical energy, when there is some kind of work going on in the form of the motion or the energy is stored. So the sum of the kinetic and potential energy is called mechanical energy. Negative value of mechanical energy indicates a bound state. For example, electron in an atom or a satellite around a planet, both are in bound state. They are under some conditions that they are bound, so they have the negative mechanical energy. Law of conservation of mechanical energy, that is the mechanical energy is the sum of the kinetic and the potential energy. Conservation means what is the value of the sum of kinetic and potential energy at the start of a process must remain constant throughout the complete process, and the final answer is same as the initial answer. So for the conservative forces, the sum of the kinetic and the potential energy at any point remain constant throughout the motion. It only depends upon the initial value and the final value. It does not depend upon the time and the position. And this law that is given in a box is law called as the law of conservation of mechanical energy. That is the final sum of the kinetic and the potential energy is equal to the initial sum of the kinetic and potential energy. Then about a linear momentum, we know that linear momentum depend upon the mass as well as also on the velocity of the object. Linear momentum can only be conserved when there is no change in the velocity. That is only possible if there is no external force applied. So in the absence of external force, the total momentum of the system is conserved. That is the P initial is equal to P final. Linear momentum at a initial stage is equal to linear momentum at a final stage, and the value is constant. Power. To do any work we require a power. Power is the rate at which a body can do the work. It is also called as a capacity to do work. It is also defined as a rate of doing work. So the formula of the power is work done divided by time. There is some another formula of the power, like average power for the complete work done is equal to change in work done divided by change in time. Instantaneous power, by taking the limit over the average value, we get a value of the instantaneous power. Also, there is a relation of the power with force and velocity, which is very important, and this can be only possible by writing the expression of the work done F dot ds in the vector form and divide by the dt. Then the F dot ds over dt comes out to be velocity. SI unit of the power can be calculated from the expressions or the units of the work and the time. So as the unit of the works are the joule and for the time is second, so SI unit of power is joule per second. Dimensions of the power is M1, L2, T raised to power minus 3. There are some other important units, that is the horsepower. So 1 horsepower is equal to 746 watt. Watt is also the SI unit of the power. When two objects collide against each other, that is called as a collision. So for the collision, we consider an isolator system in which the system is completely isolated from the surrounding and only the particles inside the system can interact with each other. They can collide with each other, exchange their energy as well as momentum. So collision is an isolated event in which a strong forces act between two or more bodies of a system for a short time, and as a result of which the energy and momentum of the interacting particle changes. But the most important thing to note that the total momentum remain conserved in any type of collision. So there are the different types of the collision. The first one on the basis of the direction. The number one, head on collision. That is when the particles are moving along a straight line. So if the motion of colliding particles before and after the collision is along a straight line, that there is no other path for the particles to move, then it is said to be head on or one dimensional collision. You can see it in the figure that the particles are moving in a straight line and after the collision there is a change in the velocities of the particle. The second type is the oblique collision. If the direction of the motion of the colliding particle are not along the initial line of motion, then that is called as the oblique collision. Like for example, in the diagram, before collision, the two particles, one is moving with the velocity u1 and another one having the mass m2 moving with velocity u2. When they collide, they move to the different directions, not in the same initial line, not along the one dimensional. So such kind of the collision is called as the oblique collision. Now the another type of the collision is on the basis of the conservation of the kinetic energy. The first one, that is a ideal condition, elastic collision, in which kinetic energy is conserved. That is, kinetic energy before the collision is equal to kinetic energy after the collision. Next type of the collision is a inelastic collision in which kinetic energy is not conserved. You can see in the picture also the two objects collide with each other. Kinetic energy before the collision is greater than as compared to the kinetic energy after the collision, because in this case after the collision kinetic energy converted into some other forms like heat energy, sound energy. Perfectly inelastic collision. In this collision, two bodies stick together or move with the same velocity after the collision. You can see in the diagram that the two objects stick together and then they start moving with the same velocity, and for this case momentum remain conserved. Or in all these three types of the collision, there is only change in the kinetic energy. Now let us solve the derivation for the perfectly elastic head-on collision. So for this we consider two masses m1 and m2 moving with the velocity u1 and u2 before collision. When they collide, this is because the velocity u1 is greater than the u2. Then after collision they start moving with their final velocities v1 and v2 in the same direction. So we know that for the elastic head-on collision there are the two things that we are going to discuss. The first is a conservation of momentum, and the second one is a conservation of the kinetic energy. So by the law of conservation of momentum before the collision of the system is equal to the momentum after the collision of the system. That is, the initial momentum is equal to the final momentum. So we put the values and take the masses m1 and m2 common, and we get the equation number 1. Then we apply the law of conservation of kinetic energy. Kinetic energy before collision is equal to kinetic energy after collision. Then take the masses as a common, and we get the equation number 2. Then we can solve the equation number 1 and 2, and we can apply the formula of the mathematics, that is the identity a square minus b square, on the equation number 2, and we have the equation as the final answer after solving u1 minus u2 is equal to v2 minus v1. Hence the relative velocity of separation is equal to the relative velocity of approach. This is called the Newton's law of impact or the Newton's law of elastic collision. So from the velocity of approach and the velocity of separation we get a new definition of the coefficient of restitution. This is practically important for the concept of the collision, and this is denoted by the symbol E. It is defined as the ratio of the relative velocity of separation and the relative velocity of approach. So for the perfectly elastic collision, relative velocity of approach is equal to relative velocity of separation. So the coefficient of restitution is equal to 1. But for the perfectly inelastic collision, v2 minus v1 is equal to 0. That is, the relative velocity of separation is equal to 0, and we have the v2 is equal to v1. Hence E is equal to 0. For inelastic collision, E lies between 0 and 1. The value of E is 1 for elastic collision, 0 for perfectly inelastic collision, and remember E lies between 0 and 1 for inelastic collision.